As you can see from the beginning of this video, I have been finding some things to occupy my time during the shutdown. I've been playing around with drones. I have two of them. And this one is an HS510. Very nice, inexpensive drone. Does a real nice job with video, although it's not image stabilized. It still works very well. And I have another one that does have image stabilization. This is a Mavic Mini drone. Works beautifully. The problem with both of these drones is the color and the size. If you look at them, they're almost the exact same shade of gray, and that creates a problem. When you put this thing up 100, 150 feet into the air, it just about disappears. On a sunny day, it's hard to see. On a cloudy day, it's even worse because it's the same color as the clouds. So I decided to build up a drone beacon or strobe using LEDs that would make it better for me, easier for me to track this thing up in the sky. Even more exciting, you run it at night, you can see it quite clearly. Let me turn this one on, and if you take a look, on the front of the drone is a blue LED, and on the back is a green one, and it's flashing fairly rapidly, and this is quite visible at a distance. I've seen it several hundred feet away, probably closer to 400 or 500 feet. On a cloudy day. This has the LEDs mounted about 3/4 of an inch above the board, which is nice if you're going to have it on top of the drone. And as you're flying towards, usually tip a little bit. It'll be very much focused on the person flying the drone. And what I'd like to do in this video is to take a few minutes to show you the design decisions I made, the parts that I used, why I used them, the user interface that allows you to interact with it. Let's start off with the battery. I have a GoPro, and I looked at the GoPro battery and said, you know what, that is about an ideal size and an ideal amount of power. These things are well over 1,000 milliamp hours, which is going to run that strobe for probably a couple of days. And I designed a circuit board that fits right over the battery, and it has a couple of ears sticking out either side. Those ears allow me to take a rubber band, hook it on one of the ears, wrap it around the bottom of the drone, and come up the other side and hook it on there, and you've got a nice flexible way of mounting it to the drone without damaging anything. You can easily get it on and off. And this is designed to be lightweight and small, and let me show you some of the parts that I decided to use in order to get this thing operating. First of all, the microcontroller that allows it to blink in different manner, different types of blink patterns, is a PIC 12F683, I believe. And it's a surface mount device. I don't know how well you can see it on the tip of my finger, but if I put the pencil eraser next to it, the pencil eraser is actually bigger than the microcontroller. That particular microcontroller has 8 pins, which is more than enough because I'm really only going to control an LED and look at a button. In addition, I have a tiny, tiny component, even smaller than the microcontroller. I'll put the pencil lead next to that. It's about as big as the exposed part of the pencil lead on my pencil. That is a MOSFET, which is a type of transistor. The LEDs draw so much current that you can't connect them directly to the microcontroller. You have to fire a transistor with the microcontroller, have that device then power the LED directly. Speaking of LEDs, what I decided to do for those, I have a number of these. I call them star LEDs. They're an LED with a large aluminum heatsink surrounding it. That's what makes up the star. These LEDs get quite hot, particularly if you leave them on for an extended period of time. But this was a little big for what I wanted to do, and I found a vendor that sells the same LED without the aluminum heatsink. And I found that if you don't have these on continuously, which we don't in this case, they don't get that hot, and it'll work real well without the heatsink, and it gives me a lighter weight device. There you can see I'm just touching the power from a cell phone battery to that. That's the green one, and this one here is the blue. Hopefully you can see that pretty clearly on the camera. This is another battery that I've been using with the drone beacon. This is a BlackBerry battery from quite a maybe 2, 3, 4-year-old BlackBerry. These were also new old stock. and every one of them that I bought has been working perfectly. Again, it's going to run that blinking LED for hours and hours and hours. The other thing that I added to the board before I had it fabricated was a socket for a charging port. I opted to use a mini USB socket that's soldered to the board, so you can plug in a USB cable, charge the battery, unplug it, and go ahead and make use of that. So those were the design decisions that I made in terms of what's on the board. In addition, I gave the option of rising or lifting the LEDs above the board. I mentioned on this, let me pull that LED off of there for a minute. This LED is actually mounted on two little extensions. They're called bullet connectors that allow me to solder those to the board and then raise the LED up above the board. There are some larger holes on the circuit board that allow that to happen. So there's some mounting options. Or you can, of course, mount the LEDs right on the board, as I did on this one. Again, a blue one on one end, a green on the other. These are not aimed straight out forward and back, but they're angled forward and back. So if this is on the bottom, you're going to see that quite clearly. Okay, now that brings us to the user interface. You may notice that it's blinking a number of times, and with a little bit of luck, it's going to shut down. I'll show you how that works in a minute. I programmed the device to have 5 modes, 5 different blink modes. So let's wake this one up. In order to wake it up, you just touch the button, and this one happens to have 2 green, and it's going to brighten, brighten, brighten until it's fully bright, and it's going to go into one of the modes, whichever one you left it in the last time. This one, I believe, is mode 1, which is a number of rapid blinks and then a pause. If you want to go to the next mode, you just hold the button down, and it's giving me a bunch of flashes. That flash was 1, 1, 1, 1. That's now in mode 1. If I hold it again, it'll go 2, 2, 2. If I let it go, it's now in mode 2, which is a faster blink. Hold it again, 3, 3, 3. Let it go, it's now in mode 3, which is a half second on, half second off. Do it again, 1, 2, 3, 4, 1, 2, 3, 4. It's now in mode 4. And again, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. Let it go. It's now in mode 5, and it's blinking single times. Now it's back into mode 1. So you just kind of go in a circle, and it flashes out the number of the modes you're going to go into. And finally, if I hold the button down so that it shows the mode that's coming up 5 times, it goes full bright, and you'll see it's dimming, 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 dimming. It's now off. The thing that's really neat about this, when you turn it off, it goes into a sleep mode that draws an extremely small amount of power. This battery is likely to power this thing in sleep mode for a year. So that if you happen to forget to charge it, and you did take the time to turn it off, chances are good it's going to have enough power left to get you through a flight or two. If not, just plug it into USB in a rather short period of time. It'll be ready to go. Now this is programmed in PicBasic Pro, which I know many of you do not have or have access to. And one of the things I'm working on that I'd like to put into the next video that I'll do is how you can do the whole thing with an Arduino-based processor. This is not an identical board, but a functionally identical board that's using an Arduino IDE for programming. So we can look forward to seeing a video that explains how you do this. Not particularly difficult, and it'll allow you to create your own modes using the Arduino programming. As usual, if you have any questions, drop me an email. I've got a lot of detail and photographs on my webpage at davebodner.com and trainelectronics.com, and you're more than welcome to visit there. I'll leave a link in the comments below. Thank you.